Okay, last video for real. So we figured out this one, 9 kilograms times 3 meters per second squared is going to be 27 newtons. Easy peasy. Using the same strategy here, force F net equals mass times acceleration. 5 kilograms of mass, 40 meters per second squared of acceleration. 5 times 40 is going to be 200 newtons. And now going on to the next one. Okay, a net force of 52 newtons acts upon a 4 kilogram rock sitting on the ground. Calculate the rock's acceleration. So A equals F net divided by M. Okay, so net force is 52 newtons divided by 4 kilograms. Here comes my trusty calculator. 52 divided by 4 is going to be 13 meters per second squared. A equals 13 meters per second squared. Okay, and what is the mass of an object if a net force of 17 newtons has caused it to accelerate at 1.5 meters per second squared? Well, mass is equal to F net divided by A. So I'm going to copy this and rearrange things. Divided by the acceleration. So this is F net. Okay, so the F net is 17 newtons divided by 1.5 meters per second squared. So 17 divided by 1.5. It's going to be 11.3. And again, we do not need to worry about all of these threes. I see that the information that we're given goes to the tenths place, so that's as far as we're going to go here, just 11.3 kilograms. Okay, so a 10 kilogram object is accelerated upward at 2 meters per second squared. What is the net force that caused the acceleration? A 10 kilogram object is accelerated at, okay, so F net equals mass times acceleration, so 10 kilograms times 2 meters per second squared. Easy peasy is a net force of 20 newtons. What is the mass of an object that requires a net force of 25 newtons to accelerate at 5 meters per second squared? Okay. Okay, so it says it in a funny way, but really this is just like mass equals F net over A. So the F net is 25 newtons and divided by 5 meters per second squared. So 25 divided by 5 is just 5 kilograms. All right, last slide and we are done. Okay, force diagram. A student is pushing a 50 kilogram wheelbarrow with a force of 600 newtons because they're super strong and it's a super heavy wheelbarrow. Another student measures the speed of the cart and finds the cart is only accelerating at 3 meters per second squared. How much friction must be acting on the cart? So this is a couple step question. So we have 600 newtons of force going this way, 50 kilograms going this way, an unknown amount of newtons pushing in the opposite direction, and we have an acceleration of 3 meters per second squared. So let us figure out the net force first. So yeah, because we have these pieces, but if we can figure out what the net force is, then we can figure out this force from there. So F net equals mass times acceleration. We love you equation. And the mass here is 50 kilograms, and the acceleration is 3 meters per second squared. So 50 times 3 is going to be 150 newtons. Okay, so that means that the total amount of force that is overcoming the frictional force is 150 newtons. So we can do this in a crazy algebraic way, or we can just be like 600 minus 150 is going to be, that is going to be 450. So 600 newtons minus 150 newtons equals 450 newtons. Okay, so the force of friction is 450 newtons. And that's the end. Okay, bye.